Hey everyone, and welcome. Today we are talking about some of the most valuable and completely invisible real estate in our entire solar system. We're going to tackle a question that sounds simple but is actually super tricky. Where in the world do you park a billion-dollar spacecraft? All right, let's get into it. I mean, just stop and think about that for a second. Space is just mind-bogglingly huge and empty. So when you launch something like the James Webb telescope, a piece of technology worth billions, where do you put it? You can't just let it drift aimlessly. You need a stable, predictable spot for a mission that could last for decades. So where is the cosmic parking garage? Well, believe it or not, the answer is right here in this diagram. The solution isn't a place. Not really, but a point. Or to be more precise, 5 of them. These are totally invisible spots in space where the laws of physics, gravity, and motion create this perfect equilibrium. They are the solution to our cosmic parking problem. So how did we even figure out these magical spots existed? This wasn't some happy accident. Nope, it took a true genius, a mastermind of mathematics and motion, to even imagine that they were possible. And that mastermind's name was Joseph Louis Lagrange. Born way back in 1736, he took on what's known as the three-body problem, one of the most difficult puzzles in all of physics. It sounds easy, right? Just predict how 3 objects pull on each other with gravity. But in reality, it is so incredibly complex that we still don't have a perfect general solution. But in his search for a special case, a specific solution, he found something amazing. And this is what he found. We call them Lagrange points. In his honor, of course. They are these unique spots where the gravitational pull from 2 huge things, like, say, the sun and the Earth, is perfectly balanced out by the motion of a much smaller object that's orbiting with them. Okay, so how does that actually work? What does it mean for forces to be balanced out there in the emptiness of space? Well, it all comes down to this beautiful cosmic dance, a gravitational balancing act. And really, it all boils down to this one simple, powerful idea. The whole concept hinges on a perfect equilibrium of cosmic forces. You can think of it in 3 steps. First, you've got the constant gravitational tug from 2 big players. Let's stick with the sun and the Earth. Second, you have the motion of your little object, like a satellite, as it orbits right along with them. At a Lagrange point, those 2 forces just cancel each other out perfectly. The satellite is being pulled for sure, but its own momentum keeps it right in that sweet spot, almost locked in place. And this is what happens when you apply that balancing act to our own Sun-Earth system. You get these 5 unique points. If you place a spacecraft at any one of them, it will orbit the sun at the exact same speed as the Earth, which means it stays in a fixed position relative to us. How cool is that? Now, here's where it gets really interesting. Not all these points are created equal. You have L1, L2, and L3, which are called unstable. They're all on a straight line between the sun and Earth. Think of a spacecraft there like a pencil balanced perfectly on its tip. The slightest nudge, and it's going to fall over, it's going to drift away. But then you have L4 and L5. These are stable. They form these perfect triangles with the sun and Earth. An object there is more like a ball sitting in the bottom of a bowl. If you nudge it, gravity just gently pulls it right back to the center. Okay, so this is all fascinating physics, I get it, but let's get to the payoff. Why on earth do we spend so much time, money, and effort sending our best missions to these invisible points? Why does a discovery from the 1700s matter so much to us today? It all comes down to this one number, 5. 5 very specific, very special, invisible spots in space that have completely changed how we explore the universe. Because these points are the absolute prime real estate of the solar system. Take the James Webb Space Telescope. It's parked at a point called L2, which is about 1 million miles away from us. Why there? Well, from that spot, it gets a constant, freezing cold, uninterrupted view of the deep universe, perfectly shielded from the sun's heat by the Earth. And because it's sitting in that gravitational sweet spot, it needs very, very little fuel to stay on course. That means its mission can last for years and years longer than it could anywhere else. And this quote right here, this is the fundamental idea that makes it all possible. This stability is why we send our most advanced solar observatories to the L1 point, to get that constant, unwavering view of the sun. It's why deep space telescopes like Webb go to L2. It's the practical, universe-altering application of a mathematical theory from almost 250 years ago. Just amazing. So, yeah, from a simple mathematical curiosity to the home of humanity's most advanced eyes on the cosmos, Lagrange points are truly special. They are our quiet, stable outposts in the solar system, letting us peer deeper into the universe than ever before. Which just leaves us with one final exciting thought. What new discoveries will these cosmic parking spots unlock for us next?